right? I'll use pow there, right? Okay, so now if I use 2 and 1,
Physics?
2I plus j. So now I know this thing is not pointing in the correct way. Right? Should be pointing things like that, right? So like that for the most part. We have a magnitude of root 5. Magnitude of root 5 there, pointing that direction. So every single point in the plane, I'm going to take its xy pair, and I'm going to put it in this function. It's going to create some sort of, big pile of vectors.
Yeah.
So that big pile of vectors, which is happening everywhere, describes the flow of some fluid, whether it's electric or whether it's actual water or whatever it is. So now I have this other function superposed on this vector field, and right along each of the points on the curve, due to this, right, the points of the curve that coincide, they're each going to have some vector associated with the point on the curve. So now when I take a line integral or something, right, I'm integrating over this line, I'm integrating over this curve, but what am I integrating? I'm not integrating its distance from the x-axis anymore to create some sort of area, you know what I mean, like in Comp 1, I'm taking all these vectors, I'm adding them up, each one. That's what my integral's doing now. Because every integral is just adding up a bunch of stuff, right? These line integrals and the surface integrals and all those integrals we're going to deal with in Comp 3, they're just going to be adding up a big pile of vectors along some curve. So when you go into 3 space, right? Well, now instead of that, I've got some kind of goofball, I don't know, a hemisphere or something sitting there. But for every point in that, right, all along the hemisphere, right, if you can imagine back there's some pointing out of the, right, that's all on the surface of the hemisphere, right? Okay. All these things pointing out of the surface of the hemisphere. So now when I take a surface integral and I integrate over the entire surface of the hemisphere, what am I adding up along the surface? I'm adding up every single
magnitude of vectors. Magnitude is everything.
Not just the magnitudes, but even the directions. Yeah, the directions. Everything. Yeah, everything. And then once I add all that up, I will know the total flow through the surface.
Huh.
Yeah, that's the idea. So that's why Count 3 was constructed for the most part. So then what they just found out was that there's easier ways to compute these integrals. So one way to compute this integral is to compute, take an integral of every single thing inside the hemisphere. I could add up every single vector inside the hemisphere.
Okay.
Right? So doing that ends up being the same as integrating along the surface. I'm trying to think of an example.
So you're saying kind of like the volume inside is equivalent to the surface of the sphere? Is that what you're talking about? Or?
Not geometrically, but what's happening vectorially. Yeah, that's right. So there's two things now. So you got in 2 space, let's say you have this, and you have things flowing out or whatever. You've got a source, right? As opposed to a sink goes in, source goes out, right? So you got something flowing out. So one way to figure out what the outflow is to add up every single outflow that's in here, right?
Okay.
I can add up every single outflow that's inside this thing. Or it turns out I can add up just what's on the surface, right? So instead of taking a
because it should be this. Yeah, it should be the same, right?
Yeah.
Because if they start from there and it's a vector, it should be. Does it pass through the surface, or does it?
Yeah, theoretically, yeah. That's the idea. It's supposed to mimic that kind of activity. Yeah. Really, they're just kind of sitting there. But yeah, that's what they're describing. You can either take an integral over the whole area like that and compute things, or you can take an integral around you can take a line integral around the thing, right? So in 3 space, you're trying to mimic the same thing. So there's surface and there's interior. So when you're in 2 space, the surface is 1-dimensional and the interior is 2-dimensional, right? Your perimeter is 1-dimensional thing, and the inside is a 2-dimensional space, whatever you want to call it, a 2-dimensional area. So in 3 space, your surface is 2-dimensional, right? This is just the surface of the hemisphere is just a flat thing that I've happened to, bend around a particular shape. It's really a two-dimensional object. But inside is a three-dimensional volume. So instead of taking a three-dimensional volume integral, I take a triple integral, I can break it down to a double integral and just integrate over the area around it. As opposed to doing a double integral here to compute an area, I can take a single integral around the outside and compute the same thing. So that's kind of what these Green's theorem. So this is like Green's, and this is like Stokes, basically. But they're all kind of.
You're saying, yeah, they're all
right.
versions of Stokes. Yeah.
In a sense, yeah, that's the way to look at them. Yeah. It's not all that simple, but I'm just saying that's the
Main idea.
that's the big idea.
Nice. That's cool.
Yeah.
Physics. We're on chapter 11.
Yep.
Wait, what? You're taking each class or a 5 week?
5.
So when did this class start for you?
Same time yours did.
Yeah, but you're on chapter 11 already.
That's where it starts.
Which chapter you on?
You're on chapter 3, right?
2. We're in chapter 2 already.
Oh.
He's on chapter 11 on homework.
Well, technically, this is like chapter 1.
Chapter 2 is chapter 1 for us, and chapter 11 is chapter 1 for him.
That's really cool.
Calc 1. Wait, how many chapters are we going in? Calc 1?
How many chapters? 4.
4?
2, 3, 4, 5, and then one section of 6. Just one section of 6.
Okay.
That's pretty good.
So it's
Really 4, yes.
so it's like 4 exams of 5 chapters, and then the final is like 6.
No, 4 exams, 1 for each chapter, but the last chapter, chapter 5, has the additional 6.1 in it. That's the way I look at it.
So it's like the 5th chapter is on the final, right?
Yeah, everything's on the final. The final is completely cumulative. But each other test is just per chapter.
Okay, but
Yeah.
but chapter 4 is only on exam 4.
Chapter 4 is on exam 3.
Okay.
And only chapter 4. And then chapter 5 is exam 4, but there's
Little
an
bit.
additional section there, 6.1,
Yeah.
that's put on there. Yeah.
How much do you know with chemistry? Have you taken Chem 102 yet?
Nope.
When is all my kid?
Oh, dang.
For examples,
Take physics.
Yeah.
Wednesday are going to cover review, or is that going to be like another class study?
On Wednesday will we say what again? On Wednesday will we?
Wednesday we're going to like study all the things we did prior to that, or are we just doing it?
There is one section on Wednesday, right? There's either 1 or 2 sections on Wednesday. I think there's 1.
Yeah.
There's one.
I think that was 2.
Yep.
Last time I looked, it was 2.
Which calculus are we learning?
We're on 1.
What? 1.
I mean, like, so are there different types of calculuses? Like Newton has his,
This is-
and Leibniz had his, and
Transcendental.
No, it's all the same. They just have different ways of looking at it. It's all the same. It's all the same thing.
PG chemistry.
There is called derivative calculus and integral calculus.
I got it.
which one was
Oh,
Newton?
wait, I did see you in
'Cause
this,
I
right?
know
Yeah.
Newton, like,
Forgot where.
wasn't he really? He
somewhere on
discovered it
campus.
first, and then Leibniz
I think it was
discovered
in
the
the math lab
calculus
or
based on
that
his
big
work
Ray
was
Ridge building?
independent,
So that's the
I don't know.
there's 2 questions.
Yeah, I
One
don't know.
is who discovered it first, and was it an independent discovery? So those are real questions that mathematical historians deal with. And there, back then